Alright, so we're going to try the other method, the p-value method. So this problem is soft drink consumption. A researcher claims that the yearly consumption of soft drinks per person is 52 gallons in a sample of 50 randomly selected people. The mean yearly consumption was 56.3 gallons. The standard deviation of the population was 3.5 gallons. Find the p-value for the test. On the basis of the p-value, is the researcher's claim valid? Alright, so just like we did before, we still have to figure out what all the numbers are. So we get that the mean mu is 52 gallons. Our sample size is 50 people are selected, and their average is 56.3 gallons. And the standard deviation of the population, sigma, is 3.5 gallons. And this time he claims that the yearly consumption of soft drinks per person is 52 gallons. So the average is 52. That's our claim. The alternate is not 52. Okay, so this time, the next step is to compute the test value, which is still the same formula, x bar minus mu over sigma over the square root of n. So this would be x bar 56.3 minus 52 over 3.5 over the square root of n. So square root of 50. Sorry about that. Plug that into our calculator. Plug that into our calculator, and we get 56.3 minus 52 divided by 3.5 divided by the square root of n, which is 50. We get 868. Okay, so the p-value is to go to, just look it up on the table or use your calculator. But this time we're going to use table E, and since we're bigger than 3.4, we're going to write down 0.0001, and because it's a two-tailed test, we're going to multiply it by 2 and get 0.0002. Now this thing is way less than 0.01, so that means that we are going to be, even for an alpha of 0.01, 0.05, anything, this means we're going to reject the null. You reject the null if the p-value is less than alpha. And if it's a two-tailed test, you have to double it. Okay, so that's our D. E then, since our claim is the null, we'd say there is not enough evidence to accept the claim. Alright, if we say we wanted to do this on our calculator, because this will do the p-value method, hit stat, test, and because this is a z-test, because we know sigma, we go to this one right here. Now we put in statistics because it's not about data. You put in your mean, which I've already done, standard deviation of the population, mean of the sample, how many in the sample, and then you pick your alternate hypothesis and you hit calculate, and you'll notice that it gives you the test value of 8.68, which is what we got. It gives us a p-value. Now this one's more accurate, so this is 0.0017 zeros, and then so this one's really small, which tells us then that, again, because it's less than any alpha we could ever possibly imagine, we would reject the null, and there's not enough evidence. So this is a quick way to get the p-value.